Section 10.4, finding the probability of disjoint or overlapping events. So we introduced probability in the last section. Now we're going to take a look at what happens when you have what are called compound events. You've got two different events that are occurring, and sometimes what happens with those events is you may have some intersection of outcomes from each of those two given conditions, and we'll take a look at that here. So here we have a Venn diagram where we're looking at two events A and B, and in the first Venn diagram here on the left-hand side, we see that in this case we have 4 items within each of our individual events of A and B that are common, and this is known as the intersection of our two events. And what we want to do is, when we're talking about probability of these two compound events, we don't want to double count events from A and B. So what we do is we get rid of these 4 events, and we end up with just the events for A and the events for B that do not overlap or are counted twice. So this would mean we have 2 types of compound events. One, we could have an overlapping compound event where you have 1 or more common outcomes, or you can have a mutually exclusive, also known as a disjointed compound event, where you have 2 events that have no common outcomes. So let's take a look at some of these examples here, and we'll be able to peek at some combinations being used in terms of probabilities this time. So the probability of compound events breaks into these 2 categories, this overlapping category and this mutually exclusive category. And the overlapping category, again, removes what's being shared between the probability of the events A and B independently. So in this case, your overlapping probability of A and B occurring subtracts the probability of A and B occurring at the same time. Now, both of these compound events are an OR type of problem. We will take a look later on at an AND type of problem. So our overlapping one is the top, and your mutually exclusive would be this next one here. All right, 6-sided die is rolled. Find the following probabilities. What is a probability? I roll it 1 time, and in doing so, I roll a number that's less than 3, or it happens to land on a number that's greater than 5. So in order for me to consider this probability, I take into consideration whether or not, when I roll the dice once, can I get at the same time a number that's less than 3 and a number that is greater than 5. And if you think about the die rolling on a table, there's no way for that to happen, right? You can't have a number that's less than 3 or less than 5. So what happens here is these are what we consider mutually exclusive. These outcomes cannot happen at the same time. And therefore what we get is the probability of rolling a number less than 3 plus the probability of a number that's greater than 5. And the probability of a number less than 3. Well, if we think on a die, we have 1 and 2. So those are 2 numbers out of the 6 that are less than 3. How many are greater than 5? 6 is. So that's 1 number out of the 6 that's greater than 5. And we have common denominators. So 3, 6. Or a 1 in 2 chance, or 50% chance, that I roll it once and get something that meets those conditions. What about the probability of rolling an odd or a number less than 3? So I think about this condition. I roll the die once. Can I, at the same roll, end up with an odd number and a number that is less than 3 that is also odd? If you think about this condition, 1 is odd and 1 is a number that's less than 3. So now we have overlap. Our overlapping compound event states that I would say consider the probability of each event individually. So the probability of getting an odd plus the probability that a number on the die is less than 3. And now, because I have an overlap of this number 1, which is both an odd number and is a number of less than 3, I don't want to double count it. So we're going to have the probability of an odd number less than 3. Subtract that one out. Probability of rolling an odd, there are 3 odds out of the 6. Probability of rolling a number less than 3, there are 2 of those that are less than 3. Probability of rolling both an odd number and a number that's less than 3. So there's only one odd number that's less than 3. So I get 2 plus 3, 5 minus 1 is 4, 6, or a 2/3, 66.7% chance that I will roll an odd and a number that's less than 3. All right, survey. Experimental probability. Survey of 100 students was taken. 92 said they can either own a car or a computer. 65 of those 100 own a car. 82 of those 100 own computers. And we want to find what's the probability that the randomly selected student will own both a car and a computer. All right, we think about our condition. Is it possible for a student to own both a car and a computer at the same time? And the answer is yes. I can do both a car and a computer at the same time. So when you can have two things occurring at the same time, you have an overlapping situation there. And so now we have to take into account our probability of an overlap. And our probability of an overlap in this particular situation says we want the probability of having a car or a computer, and that's going to be equal to the compound event of having a car plus the probability of having a computer, but then now we remove the probability that somebody has both a car and a computer. I want you to start with these generic probability setups first. Don't just start putting numbers into this. So we start out with our generic compound equations. Again, the overlapping one is subtracting. All right, then we look at what I have. Like any equation, I can solve for any part of that equation if I knew the other components. So in this case, in terms of probability of a car or a computer, we know that there are 92 that have that. So out of the 100, I already know this probability. There are 92 of the 100 that own both a car or a computer. And then we also know that there are 65 out of the 100 that own just the car. And that there are 82 of the 100 that own just a computer, or just own a computer. And so what we're looking for is this. The question is asking us for how many of them, or what's the probability that when they pick this student, he or she will be somebody who owns both, car and computer. All right, so we set this thing up, and we just combine our like terms. Here we get 147 over 100 minus the probability that we own a car and computer at the same time. Now, probability is always positive, so when I subtract this 147 to the other side, I get a 55. It's negative right now, but I have a negative probability, so I just am dividing out that negative 1 from here. This is what's going to give me my positive probability. I'm going to divide the negative 1 out. So I have the probability that I own both a car and a computer is a 55 out of 100, or an 11 out of 20 chance that that'll happen, based basically, I have 11 people out of 20. I have 20 in my lineup, and I say 11 of you would have both a car and a computer. Complements. What a complement is? Well, when we're talking about permutations and combinations, we considered that one way of finding the total number of ways something can happen was through the process of subtracting from the total ways that something subtract from the total number of ways something the things that you do not want. So we said subtraction was a possibility for coming up with counting number of ways of an item. And that is really what's happening here with the idea of a complement. We are subtracting from 100%. Again, if I have the probability of an event happening and the probability of that event not happening, those two probabilities have to add up to 1. And so a complement just says, let's take a look at what if you subtract the probability of something happening or probability of not happening from 1, and we can come up with this idea of a complement. So when we want to use a complement, you will generally, got the word not in there. The probability of some event not happening would be an option or an opportunity for us to use the complement. And we have this notation here, this little bar that's over our event. That's what we'll use to denote that we're talking about a complement. So we have in our first example the deck of cards again, to find the probability of not drawing a 7. So what that might look like written in complement form would be something like this. Probability of not a 7 is equal to 1 minus the probability of getting a 7. And we're just drawing one card here, so we know we have 1 minus, how many 7s are there in a deck? There are 4 out of the 52. And this becomes 52 over 52 minus 4, or 48 over 52. And this becomes 12 over 13. The probability of me not drawing a 7. Yes, you can do these problems without the use of the 1 minus. Probability of not drawing a 7 again is saying what's the probability of drawing any other card. And so we know there are 48 cards that are not 7s. And there's that number, 48 of the 52, which reduces to 12, 13. Probability of not drawing a red face card. Again, my notation would be probability red face card. I'm looking for the complement of that. Would be 1 minus the probability of drawing a red face card. All right. Red face cards. There are 12 face card total in a deck of cards. 6 of those are red though, diamonds and hearts. So I'd have a 6 out of a 52, or a 46 out of a 52 chance, which becomes a 23 out of a 26. Is the probability of not drawing a red face card. Okay, then we finally get to a situation where I've been pulling like one card at a time out. When I'm going to be pulling groups of items out, I have to think combinations, permutations. And here we're going to see that actually happen. So now I'm going to say probability of drawing 2 kings or 2 red cards. So again, remember generically probability means the number of ways an event can happen over the number of total ways. And when you're pulling more than one item, you're thinking about, well, there could be a couple different ways that I could pull 2 cards out of a set of X number of cards, for example. And that's what's happening here. I got 2 kings and 2 reds, and it's an OR event. So first, I guess we need to determine whether this is a overlapping or if it is a mutual exclusive condition. So ask yourself the question, can you draw and have in your hand, 2 red kings? Is that possible? Can I get 2 red kings? The answer is yes. I could have 2 red kings. So these are overlapping. So we have an overlapping condition here. Because I could get 2 red cards that are kings. So generically, so far I know this. Probability of 2 kings or 2 red is equal to probability of getting 2 kings plus the probability of getting 2 red. And now I have to remove from that my probability that I get 2 red kings. Okay, I'm pulling out 2 cards. So if I'm thinking about like how many ways can I draw 2 cards from 52, well, I have a combination that I'm thinking about here. So in this term of probability, I want to know how many ways can I draw 2 out of the 4 kings. So I'm thinking about my barrel of kings has 4, and I want to pull 2 of those. So that is a 4C2 way of pulling kings out. Now that's the numerator part of the probability. The denominator probability, I have 52 total cards, but out of those 52, how many ways can I draw 2 of them? Well, that's a 52C2. So there's your probability of just getting 2 red kings using combinations. Order wasn't important. Now we go back to the red cards. So there are 26 total red cards in the barrel. I want to pick 2 of those. There's how many ways you're going to pick 2 reds. Over, once again, the total number of cards. Picking 2 cards out of the 52. And now I'm going to subtract from that how many ways, so in the barrel are 2 red kings, and I want to pick both of them. So I only have 2 red kings. I want to choose both of them, so this is a 2C2. And again, I'm pulling those cards out of a total of 52. So here we see the use of combinations for probability purposes. Again, if I'm pulling out groups of items, I'm probably going to be working with a combination, or maybe even a permutation if order is somehow important here. All right, so then we go ahead and we set this thing up here. We're going to find out our combination numbers. So we go find our 4C2. And that's a 6. So we have a 6 plus a 6, and then a 2C2 is a 1. And each of these are over our 52C2, which is 1326. So I get a 12 minus a 1, or an 11 out of 1326. There's your probability of drawing 2 kings or 2 reds. I think that's it.